I probably shouldn't have played that because it was too good. It's like too powerful. I love that song so much. There's a lot in there, but first of all, you notice Aaron's beard? I believe he's referring to Moses' brother there. He's a very religious guy. He went to Hope College, actually, which is similar to Gordon in Michigan. But I think it does well to get in touch with the empty feeling, the emptiness, feeling there's no reason to live, real despair in the song. But then it has this other part of it where he's like trying to fight through, and you feel that energy come up when that riff comes up at the end. Don't back down, and trying to move on and fight and live. Concentrate on seeing the breakers in the bar, the neighbors greeting. I don't know what the breakers in the bar means, but it's something, that's like in front of him, I think. And the neighbors greeting, like concentrate on like the day-to-day, putting one foot in front of the other. Sometimes that's what you got to do when you're depressed. Or you're feeling that despair, so. What else is really good in there? I should have wrote a letter explaining what I feel, that empty feeling. Oh, when I was three, maybe 4. So he's like wrestling with so his mom had schizophrenia. Crazy. Talk about like a stressor, and that brought a lot of challenges for him. I think it brought a lot of meaning to his life as well. But she left him at that video store when he was 3 or 4 years old. Perhaps maybe when she was in a psychotic episode, I don't know. My black shroud. Yeah, there's a lot of good images in there. So I don't know if anything hit anybody you want to point out, as I sort of just did. There's a few things that hit me this time I listened to it. Anything you want to discuss from this? No pressure. It looks like it did the job. You all look pretty depressed, so that's good. Just kidding. I don't want you to be depressed, but it is good, I think, to have some respect for what depression is and feel that, sadness. I think that's okay. Remember, depression isn't the equivalent to sadness. Depression is when you're sad and you have some other symptoms and it doesn't go away for like most of the day, nearly every day for 2 weeks. So hopefully after lunch you guys will feel better if this song made you sad. Same for me. While we're on the topic, though, of sad songs, how does that work for you? Like, isn't it true that it makes you feel good to listen to like a sad song. Like I would listen to this if I was depressed, or Third Eye Blind is another one. That was like when I was in college, like that was what people used to listen to when they were depressed.
Honestly, I'd rather listen to a more positive feeling song. That would just pretty much, because the sad song would pretty much feed my depression.
But that's right. So yeah, that's my point, Phil, is that yes, doesn't it just feed your depression at some point? And is it better to not do that? You stay down too long if you listen to songs that are quote unquote mood congruent when you're feeling really low? Phil has the way around. He doesn't do that. He listens to happy songs. How's that work for you? Does it make you happy?
Honestly, yeah, it kind of does. It could be better, but it's better than driving myself further into depression.
Mm-hmm.
I've been there before, and I ain't got time for that anymore.
There you go. Nice.
I found out, like, if you have something else going on, you have, like, this bank of sadness, and if you try to ignore it, then it's kind of true.
Yeah.
And, like, that's kind of annoying. But you're almost okay. But if you listen to like a sad song, you kind of just open it up, feel all of it all at once, and it's, like, really uncomfortable, but it's, like, very raw human condition. And you can kind of close it, you can go about your day, like, normally.
Yeah.
But you can't, like, wallow in it and then keep opening it up to see if there's anything else in there.
Right.
Like,
Yeah, I think that's good. It probably takes wisdom to have a balance there. But I love what you said about, when you're going through something, you have this vat or whatever of sadness. There's something real about it. I think that's what we're doing when we're really sad, is we're trying to like introspect and like process something that's tough, and I think it's probably not good to ignore those feelings. It's good to listen to, a sad song or whatever you have to do to get in touch with that. But it's also probably not good to be stuck in that groove for like forever. Yeah. Cool. All right. Well, let's get back to some more cerebral stuff, disconnected from the feeling of depression. We're going to go back to this notion of etiology. And I think I'm recording the screen over here.
Never mind.
Yeah, you're right. It's not showing the very top word. That's okay. So this is what we talked about last time. This is a review. This was the last class. Multiple factors appear to be involved in depression. Ways of thinking, behaviors, biological stuff. And then we started to talk about the neurotransmitter dysfunction idea last class. And I did a poll, and you were all like, yes, neurotransmitter dysfunction is probably important in depression. And then I told you the evidence for that is not strong. Whoops. So this is all review from the last class. This is the monoamine hypothesis, the idea that depression results from a deficit in the monoamines in the synapse. I drew the synapse on the board last class, remember, and talked about how there's less serotonin or whatever in the synapse. So this is the chemical. Okay, and sorry, this is the poll I did last time, my bad. And so, but I didn't say this last time, which is a note of caution, which is that this is a confusing lecture I'm about to go into. It's extremely nuanced. It's like more graduate level lecture than undergraduate, I would say. So I'm not just going to tell you these basic things. Like a lot of professors who teach this class would probably be like, yes, the monoamine hypothesis is that there's not enough serotonin in the synapse, and then they'd move on. But instead, I'm spending like most of a class telling you really what the research is on this, what the evidence for and the evidence against, and where evidence is lacking and stuff. I'm even going to tell you one piece of evidence that for a while was really compelling, but then it turned out to be false from another study later on. So it's like back and forth and really nuanced. So I hope that gives you some courage to like raise your hand and ask questions and stuff if you're losing me or you're not following and you're not seeing the big picture because I'm telling you a lot of details. This is a tough lecture, okay? So ask questions, especially if I seem to say something that really disagrees with a fundamental truth that you hold. Make sure you got that right or disagree with me. I love that. Love a little debate because I also say things that are a little controversial in this lecture, maybe. Okay, so the theory we're talking about is the monoamine theory or the chemical imbalance theory of depression. Low level of monoamines like serotonin cause depression. That's the theory. So how is that different? Okay, and this, I showed you this slide last time. Okay, sorry. So remember, the brain, of course, is different when we're depressed than when we're happy. Of course, it's different when we're swimming than when we're sleeping. Our brain is going to be in a different state, and no matter what activity we're in or what state we're in. But that doesn't mean that the brain caused us to be in those states, you know? It's just our brain is different in those states. So what's the evidence, actually, that the monoamine theory is true? Well, the theory is, the furthest back I've been able to go with this is 1965, this came out. This study by Skilkraut in 1965, well, actually, this was a review article of some studies that had happened a little bit before then. And he claimed in that paper that serotonin may be causal in depression. Okay, so far that's just restating the theory. That's not evidence for the theory. What's the evidence for the theory that he referred to in that paper? Well, it was this. These two types of pills worked to treat depression. They made people less depressed when they took these two types of pills. One type of pill is called an MAO inhibitor, which MAO is an enzyme in your stomach that breaks down serotonin, basically, in your stomach. So if you inhibit that enzyme, less serotonin will be broken down and more serotonin will be floating around in your body, basically. So this is, MAO inhibitor is something that basically boosts serotonin by stopping MAO, which is the breaker downer of serotonin. Does that make sense? You understand what an MAO inhibitor does? Yep.
So MAO inhibits the thing that inhibits serotonin.
Well, MAO is the thing that inhibits serotonin.
So, an MAO inhibitor inhibits
MAO.
serotonin.
Yes.
Okay.
Yes. So MAO is a serotonin inhibitor, more or less, or it breaks down serotonin. It's a catalyst, or an enzyme, actually. Yeah.
So kind of like how cancer is where cell division loses its limits, sort of. Yeah. Sorry.
Like it goes, yeah, I know what you're talking about with cancer, but I don't think that's really the same thing here. So normally, so your body produces serotonin molecules. You know, let's say they look like this. I don't know what they look like, but you know, they're floating around in your brain somewhere, and this is a blown up version of them. But then they go down to your belly, in here, and this MAO eats them up. So they no longer looks like this. They get split in half or into thirds or whatever. So there are these little bits.
Oh, I see. So it's
Okay.
kind of like how certain medications act as a base to neutralize stomach acid a bit.
Sure, it's neutralizing this enzyme here, MAO. And MAO's job is to eat up serotonin, and so into smaller bits. So what happens if you get MAO out of the equation? If you get MAO out of the equation, then you still have your normal looking serotonin molecules in your stomach, and they can get recirculated throughout your body, so you basically just have more intact serotonin molecules if you kill MAO. Yeah.
When they measure serotonin levels in the brain, is it kind of consistent in someone who is diagnosed with depression? Like, is it just always low, or is it low only when
Okay. The question from Kasaya was an excellent one, which is, but it was actually, the question was a bad question. I just said it was excellent, but then I went back on myself and said it was bad. So what does that mean? Well, it was a good curiosity, but it was a bad assumption that you had in your question. So you said, when they measure serotonin levels in the brain, you know, what happens or whatever. So that's a wonderful thing to be curious about. But you assumed that they measure serotonin levels in the brain. That is not possible to do. No one has ever measured serotonin levels in a human brain, living. Okay?
So how do they know, like how would they, like, assume this?
Because we know what MAO inhibitors do. If they block MAO, we know MAO breaks down serotonin, and we know when people take these, sometimes they get less depressed. So if basically the net effect of an MAO inhibitor in your stomach is boosting serotonin levels throughout your body, and it makes you less depressed, then maybe the problem initially was that you didn't have enough serotonin. Now we do this, we boost serotonin, and lo and behold, you're better. Maybe it was just a problem of not enough serotonin. It's the exact same thing that happened with schizophrenia, remember? We give someone a pill, it reduces their dopamine levels. We find out through chemistry studies or whatever. And then it makes them not psychotic. So maybe the problem that was making them psychotic was they had too much dopamine. This is the same thing as that. We're increasing serotonin through an MAO inhibitor, and we're saying, oh, this makes someone better from depression? Maybe they didn't have enough serotonin. Maybe that was the problem. But that's the leap we're taking. It's quite a leap. It's not like we're just observing serotonin levels in the brain like you assumed, and like probably everyone in this room was assuming was possible scientifically. It's not possible scientifically to do that. Don't have the technology for that. So tricyclics are the same thing, basically. They also boost serotonin, okay? So this guy, Skillcrowd, in 1965, is looking at these studies that have shown MAO inhibitors boost serotonin, tricyclics boost serotonin, and they both make people better from depression. So maybe depression is just a lack of serotonin. It makes sense. It totally makes sense. But this is what I call the aspirin argument. So remember last time I asked you all, do you think that headaches are caused by a lack of aspirin? And no one said that they thought that. That's basically the argument we're making here. That since boosting serotonin makes people better from depression, then depression must be caused by a lack of serotonin. That's the same as saying that a lack of aspirin probably causes headaches because aspirin cures headaches. But no one believes that about aspirin. So there must be some other evidence, right, for the depression thing. Otherwise, we'd all be idiots believing in this chemical imbalance theory. Well, let's look at that. So the aspirin argument, as I said, is let's review that. So if a pill cures an ailment, then the ailment must have been caused by the inverse of that pill's active ingredient. So an example of that is if a pill has aspirin in it and it cures your headache, then the headache must have been caused by lack of aspirin. Or in schizophrenia, if the pill blocks dopamine and it cures schizophrenia, your schizophrenia must have been caused by too much dopamine. Or analogously in depression, if the pill boosts serotonin and it cures your depression must have been caused by a lack of serotonin. So these are all the same type of argument. Yeah.
So like how, sorry, I was just checking to see if the example I was already said. So, like how an upset stomach might be caused by active stomach acid using a basic substance to counter it, would neutralize it.
Okay, sure. So if you take a substance that's a base chemically, and you eat it, and it makes you feel better, and you had a bellyache, then sure, it would be reasonable to assume, hey, maybe my bellyache was caused by too much acidity, which is the opposite of basicness, in my stomach. Yes, that would be a similar example, Phil. Very good. Do these all make sense? These are all the same argument. We get it. Yeah? No? Yeah. No? Yeah? Okay. Cool. All right. So what exactly do SSRIs do? Well, they block serotonin by, they boost serotonin by blocking reuptake. So, sorry, I should have mentioned that Skillcrowd based his argument on tricyclics and MAO inhibitors. But then since then, there's been these new pills which also basically do the same thing called SSRIs. SSRIs means selective serotonin reuptake inhibitors, and they also boost serotonin, okay? So all antidepressant medications boost serotonin. And if we go back to our little neurons talking to each other here, there's an end of one neuron, there's an end of another neuron. They want to have a chat. So this guy opens up he's got little vesicles of serotonin here, and he's going to open up his little mouth or his set of channels, to send these guys over, and then this guy is going to receive them in his little slots. And that's how he knows, he's getting a message from the other guy. But then, so, these guys go into the little slots or whatever. That happens. But then immediately after that, they like wiggle loose and they go back into the synapse. And this guy is sending out like these bigger vesicles which can kind of like envelop the original molecules of serotonin. So this guy goes over and he eats it, and then he takes it back into the original cell. So that's called reuptake. After neurotransmission, the neurotransmitter molecules are reuptaken by the original neuron that sent the message. So what SSRIs do is they block those big guys that eat them up. So they never get taken back into the original molecule, so they just hang out here in the synapse. And they keep going into the slots in the other guy. More of them are hanging out in the synapse, and so that some of them, keep hitting those slots. So it's just basically a way to boost serotonin activity by preventing the serotonin from going back into the original guy.
So the serotonin that's in the synapse, and I guess all modeling is in the synapse, it's kind of leak in every once in a while, or do they is like the function? I guess what I'm asking is the utility of the monoamines. Is it them being in the synapse in between, or is it the fact that they go in by being within the synapse? Does that make sense?
It doesn't really make sense to me.
What do we want from monoamines? Do we want them to be in the synapse, or do we want them to be in the synapse because when they are, they go in to the other neurons?
Well, yeah, they're not accomplishing anything when they're here, but if they're here, some of the time they're going to float into here. And that's when this guy gets guys in his slots, that's what starts to change his chemistry and stuff and ultimately make him do an action potential. So that's why it's important to increase in the synapse. Does that at least basically make sense to people? Yeah. I'm probably not going to force you to draw, these things on an exam or anything, but I do want you to basically know how SSRIs work. Okay. Here's something, though, that you don't understand yet, which your textbook, I don't think, would tell you, is that SSRIs and other psychiatric medications, such as antipsychotics, are dirty drugs. What that means is that when you take a SSRI, remember in the original, when I was explaining this theory, I was talking about how serotonin's in your limbic system, and that's the emotional part of your brain and stuff. So it makes sense that it's a chemical imbalance or whatever. But when you take a pill of an SSRI, you take it through your mouth. How does it get to your brain? Well, it goes to your belly, you digest it, it gets into like little blood vessel things in your stomach, and then it gets pumped by your heart up into your brain. And it goes actually through your entire body. It goes to your hands, it goes to your feet, it also goes to your brain. And it goes not just to your limbic system in your brain, it goes to your entire brain. The entire brain is washed, and body are washed with what these chemicals do. And the chemicals don't just bind to serotonin receptors. They also bind to dopamine receptors and norepinephrine receptors and even other receptors, okay? Maybe even a little to glutamate receptors, yeah.
Okay, so if SSRIs can also block dopamine, which is...
Or they would boost dopamine maybe, but yeah.
Which is highly, so if they could potentially block dopamine, which is the neurotransmitter associated with pleasure, wouldn't that pretty much be counterproductive?
Well, they don't block serotonin. They boost serotonin.
I know,
They
but
block the reuptake of serotonin.
I know, but if they mess with dopamine as well,
Yeah.
wouldn't that just completely defeat the purpose?
Well, it depends what they do to dopamine. If they boost dopamine, maybe they're like the pleasure drug. Everybody would feel great because they'd have so much dopamine floating around, right? Maybe they'd also be psychotic. Remember what happened with L-Dopa? If you have too much dopamine. But your point is basically, if your point is that, yes, this is going to mess with dopamine systems and other neurotransmitter systems as well, then that is correct. That is what I'm trying to convey here. Yes?
Are you saying that it binds to the norepinephrine and dopamine reuptake molecules as well?
Yes.
Okay.
Yes,
So it's boosting.
yes.
Okay.
So if SSRIs are also binding to like norepinephrine and dopamine, then like what's the difference between an SSRI and an SNRI?
Well, and yeah, exactly. So an SNRI, which is a serotonin and norepinephrine reuptake inhibitor, is a newer form of an SSRI. It's a matter of degree, the difference between those. So an SSRI is an SNRI because it also blocks the reuptake of norepinephrine. Ones that are called SNRIs just do the norepinephrine more. It's a matter of how much do they block the reuptake of norepinephrine versus serotonin versus dopamine and these other things. So they're all dirty. They all affect different multiple types of neurotransmitters, but it's how much do they do for each one. I forget the exact ratios, but there's a lot of overlap. So SSRIs do a lot of things. That's what I'm trying to say. They don't just block serotonin. They do a lot of things in the brain and in the body, and we don't know why they work. Theoretically, we know they block the reuptake of serotonin, but they also do other things. And what's the active ingredient in making people not depressed anymore? We don't know. We don't know. It could be the fact that they're boosting serotonin, or it could be one of these other things that they also do. We're not sure. All right. So how's that for, how are we doing? Yes.
Does bind and like block the reuptake is the same thing as?
When I say bind, I just mean it's binding to this guy who does the reuptaking. It goes in and like attaches to him, and then he can't do his reuptake no more. So binding to him is blocking the reuptake. Yeah. Does that make sense? Yeah. Yes.
Do SSRIs ever stop working for people?
Yes. Yeah, oftentimes people will switch SSRIs to another one or something. Yeah.
Stop smoking, like what would be the assumption?
There is no assumption. Just try something else. It's all pragmatic based on the outcome. So, okay, this doesn't work for you anymore. You're depressed again. Let's give you a different drug now and see if that helps. It's a trial and error. Yeah. But there's no real knowledge about, well, I know that, your serotonin molecules have adapted or whatever, and now I'm going to give you this other one that's attaches to a different, receptor site or something. It's not sophisticated like that. It's just pragmatic, based on results, trial and error. Yeah, which is fine. I mean, it works for people. Sometimes you're like, yeah, I've been on Prozac for 10 years, doesn't work anymore. They give you Lexapro and it works. So it's not like bad, but it's not based on deep understandings of the chemistry in your brain. All right, so we doing okay with this? This is like the first little story, the fact that these drugs are dirty and we don't know why they work. That's like the first point I'm making here, but I'm gonna make a lot of points. Here's the second point I wanna make. I wanna tell you about this study that happened in New Zealand. That's why there's a bunch of sheep on this picture, because they have a lot of sheep in New Zealand, okay? Just to help you remember what we're talking about. So this is a paper that came out in 2003, the year that you were born, or like 2 years after or something, right? Yeah, something like that. Yeah, thank you. Yeah, okay. So it was also the year I was a sophomore at Gordon, so that's how old I am. But within like 10 years, say by 2013, when I was in the middle of grad school, this paper had the most citations ever in the history of psychiatry within 10 years. So this is a major, major paper. You know what a citation means, right? It means someone else published a paper and they referred to this paper in their paper. So within 10 years, more than Freud, who's been around for 100 years, more than anything else, more than the Skilled Crowd review I just told you guys about from 1965, this paper within 10 years had more citations than any of those. So massive, massive impact. This Caspi paper, Caspi 2003. This paper was like the holy grail, people thought. So what was this about? Well, they thought they basically understood the bucket thing. Remember I told you about the bucket with schizophrenia? And, everybody has a bucket that can handle a certain amount of stress, but then, if their bucket overflows, then they become psychotic or whatever. They use that same theory for depression, and they said, okay, everybody has a bucket. If you have too much stress, you become depressed. That's the basic idea. And it's been known for a long time. Indeed, if you have a lot of stress, it's more likely that you'll be depressed. Whereas if you have no stress at all in your life, it's very unlikely that you'll be depressed. But there was still a mystery here, because we were like, well, person A is in, Afghanistan in the war. Person B is in his very same squadron in Afghanistan in the war. They're going under the same stress. They have identical stress. They both have a fiance at home and have no children. They're very well matched. But person A is depressed and person B isn't. So identical stresses, but why is person A depressed and person B is not depressed? That is what we didn't know. We were like, well, maybe person A has a bigger bucket than person B. Okay, fine. But can you be a little more specific and real than talking about an analogy of a bucket? Well, that's what Caspi did in this study. He said, I found the bucket, fellas and gals. So they wanted to look at life stress in 1,000 people. There's a big study, especially for 2003. They studied 1,000 people, and they wanted to see how stress interacts with serotonin genes. So 5-HTP, or 5-HTTP, I always forget which it is a gene that has to do with serotonin. It's transporter molecules. The little guy who lives here or whatever is a serotonin transporter. And this is the gene that makes that molecule, okay? So they wanted to see maybe what version of that gene you have is what differentiates guy A from guy B, who's depressed and who isn't, okay? That might be the mechanism of the diathesis. Yes, sir.
So you're saying that genes might have an impact on neurotransmitters, which is how genes
Yes.
impact emotions.
Bingo.
I've been wondering how that affected emotions.
This is one idea, yeah.
Can you just define diathesis again?
Diathesis just means vulnerability. So presumably, those two soldiers I told you about, the guy who's depressed has a vulnerability. He has a weakness within his brain or his body to become depressed, whereas person B might not have that. Under stress, he becomes depressed. All right. So they did interviews with these 1,000 people, actually followed them throughout their whole lives, starting when they were kids, and they were all like I think they were all 26 years old when they did this study. And they did, they took blood samples and saliva samples and stuff so they could look at all their genes, including this serotonin transporter gene. They followed them all since they were a baby? Yeah, they're all 26, okay. And this is what they found, and this is why this is the most cited paper in the history of psychiatry. Still today, I think it is the most. There are 3 lines on this graph, and I will even reveal the fact that I'm going to make you draw this graph on the exam, okay? So you got to know this. If you don't know this, you should ask a question. Otherwise, you're going to lose points on the exam. Nobody wants to do that, okay? You want to get this one right. This is a layup. I'm telling you, it's on there. So to understand a graph, you always start by a graph with multiple lines on it. Always start by looking at one of the lines, okay? And before you even look at one of the lines, you can look at one of the points on the lines. And then you understand the whole line, and then you understand the other lines. So let's start with, I don't know, this point here, the bottom point at 0, okay? So, and we should understand the x and the y-axis. So the x-axis is the number of stressful life events, okay? I believe this means the number of stressful life events the person has had in the last year, okay? All these 1,000 people, they're all 26 years old. How many stressful life events have you had in the past year? A stressful life event would include getting married, getting divorced, losing your job, having to move to a new apartment or something like that. There's all sorts of things, but some major shift in your life or some difficulty in your life that's a stress. So how many of you had in the past year? All right, great. The y-axis is probability of a major depressive episode. Well, what the heck is a major depressive episode? Oh, wait, you know that one. You learned that last class. Major depressive episode. You have 5 of these 9 symptoms for 2 weeks or whatever, right? So of the people that had 0 stressful life events in the past year, for this point right here, it looks like about 7% of them had a major depressive episode during that year. Okay, great. Then let's now understand the rest of this line, this one point that we've looked at so far. Let's see, I could move over. Okay, it moves up a little bit when we get to 1 stressful life event. It moves up some more when we get to 2 stressful life events. In fact, it's at about 21, it looks like. So that's triple the rate of depression with just 2 stressful life events. I move up again to 3, and it's 30. And if I move up to 4, it's like 42, which is 6 times the rate. If 6 times 7 is in fact 42, is that correct? Yes, right? Good. So yes, 6 times the likelihood you're going to be depressed if you've had 4 stressful life events. In other words, you've had a hell of a year, probably, okay? 6 times the likelihood you'll be depressed. All right, great. We're doing so good. We understand this graph pretty much because we understand one line. Now let's look at the other lines, though. Figure out what the deal is with those. Well, I don't know what these letters here mean, but I can look at this gray line, gray squares, and it's basically doing the same thing. It starts a little higher, it gets a little lower, only goes up to 30%. But it's basically the same trend. You know, the more stress you have, the more likelihood you'll be depressed. This other one here is doing the same thing as well. It starts at around 10%, but the more stressed you get, also the more likely you're going to be depressed. 20% roughly. Okay, so now somebody help me out and say, how would you characterize or describe the difference between those 3 lines? How are they different from each other? Ideally, someone who has not yet participated today. I would love to hear from. Yes?
Each line representative of different type of HT.
Maybe, but let's not even worry about what they mean. Just whatever they mean, how are they different from each other? Is Mason, right?
Oh.
You can go for it, or you can pass the baton. Yeah.
Well, each line is affected differently by the number of stressful items.
Yes. How so?
Because they really at a different, the probability of major depression episodes increases greatly depending on which one it is.
Right. Greatly or not greatly, depending which one it is. Very good. So whatever SS means, it increases at a rapid rate. Stress is real bad for these people, whoever these people are. LL, stress isn't good. It increases your likelihood of depression, but it's less of a damning effect. You know, it's only a 20% chance you're going to be depressed if you've had 4 versus a 42. That's double the rate for these guys versus these guys. Whereas if there's 0 stress involved, these guys are on top of each other. There's not much of a difference at all between them. So only when stress comes into play do we see a difference between the groups.
Something I've noticed is that the ones who had less initial depressive episodes had more later in life. So I think that kind of symbolizes.
No. What you must be misunderstanding, because this is all about people who are 26 years old.
I'm sorry, I misspoke.
Yeah,
I'm sorry.
that's okay.
This one is telling me is that maybe it's showing a difference in resistance to depression.
Yes, exactly. So what would that difference be?
What I know to say is that like since those with the fewer depressive episodes at first have a
There's no one with, there's nothing about at first here. There's no time shown in this graph. So
think it's-
the only thing we see, let me explain it, Phil, and see if you get this, is these three groups are different from each other in terms of the function that stressful life events has on them. So what this means is this is called SS is short. So there's three types of alleles for this gene. There's three versions of the gene. There's the short. So you remember, you get every gene you have, right? Don't you get one from your mom and one from your dad or something?
Right.
So like, there's a little, this is like one version of the alleles you could have. You could have short and short. Short from your mom, short from your dad. Or you could have a short one and a long one, a short and a long, that's called SL in the middle. Or you could have two of the long ones. Those are the only three options for human beings with this one particular gene. You have long, short, or short.
So it's showing which genes have a higher resistance to depression.
Yes, exactly. So SS is screwed. If you have that gene and you get stressed, there's a very high chance you're going to have a major depressive episode. Okay? If you have the long version of the gene, there's still a chance you're going to get depressed, but it's only half the chance as if you had short. It's 40 versus 20. Okay? Does this make sense? This is the bucket. This is the mechanism of the bucket. This is why soldier A, maybe, got depressed and soldier B didn't. Maybe soldier A has short. Soldier B has long. Maybe this isn't the only answer, but this could be a major part of the reason some people have bigger buckets than others. They can hold more stress than other people before they get depressed.
I see. So interesting.
So interesting. It's crazy. It's the Holy Grail. This is why it's the most cited paper in the history of psychiatry. All right, so these are just words that I have just said. I forgot to. This is called an interaction effect, by the way, between the gene you have and how much stress affects you. So what an interaction means in statistics is that you have different slopes of two things. So you're looking at the relation of an x and a y variable, and you have a slope there. And then if you bring in another variable, like gene type, and you have different slopes that are really different statistically, that's called an interaction. So this is a gene-environment interaction. The environment is how much stress you've had, and the gene is what version of the 5-HTP gene you have. So we figured it out. We understand the mechanism of the bucket in the diathesis stress theory, and the 5-HTP gene is more or less the bucket, or at least it's one of your buckets or something like that. And so serotonin is involved. So we get back to our chemical imbalance theory, and we're like, okay, maybe this isn't like how much serotonin you have, but how well you can use it or something would be affected by the 5-HTP transporter. Except for the fact that this study is false. Okay? This is the problem with Caspi. It's not true. Why would I say that? They studied 1,000 people in New Zealand. People in New Zealand are nice. They're called Kiwis. In New Zealand, they don't have an organic fruit section because all the fruit is organic there. Okay? But this study is not true. That's the one bad thing about New Zealand.
Are you saying that that study was entirely biased?
No, I didn't say why it's not true, but I'm gonna tell you why I think it's not true right now. So this is a study by Culverhouse. They came out in the journal Molecular Psychiatry. Now, Caspi came out in Science, which is the baddest ass journal in science, and it's tied with Nature. Nature and Science are like, if you publish in those, go get a job at Harvard. You know, your career is made. You're going to be great. But JAMA, Journal of the American Medical Association, and Molecular Psychiatry are like just a hair underneath. They're like the Science and Nature of psychiatry. So these are phenomenal journals. And these two studies by Risch in 2009, 6 years after Caspi, and Culverhouse, which came out 14 years after Caspi, they are both meta-analyses. So a meta-analysis is just a study where you ask a ton of other researchers who have already published on something for their data. And they send you their data, and then you combine the results of like 20 studies to get like some mega study that's really trustworthy. You know, you have like tens of thousands of people in your study instead of just 1,000, like all the individual studies had. So both Risch and Culverhouse did that, and these are the studies that they included in their analysis, including CASPI was the first one. They had this one that had 300 people, this one that had 2,000 people, this one that had 1,400 people. All told, it was 14,000. This is from Risch, actually. This was the first one that came out. And don't worry really about, well, actually, yeah, you can worry about this. This right here is the average of all of the studies, what all the studies found here at the bottom row. See, it says overall. And the further to the right this dot is, the further, if it's on 1, it means there's no effect for that factor in determining depression. So the risk per S allele, in other words, short, or long, long, short, long. I mean, how many short ones do you have? There's really no risk there. There's no difference between, it's basically on 1. So which version you have doesn't matter. How many stressful life events you've had does matter. This is different than 1. So that, as we've always known, is true, that the more stress you have, the more likely you're going to be depressed. This is the effect of the interaction between stress and the gene, and this is even more so on 1. There is absolutely zero effect of the interaction term in this analysis. It's a little statistical geek that I'm getting right now, but it just means that if we look at this graph, if we made this graph for all the studies, and then we averaged them all together, the 3 lines would be directly on top of each other. They wouldn't fan out like they did in the original CASPI study. So there's actually, so this was with 800 some odd people, almost 1,000. I rounded up when I first explained it to you guys. This is what it looked like for the first 800, but then after humanity had studied 14,000 people, there's zero effect. These lines are on top of each other. There's no interaction. And then Culverhouse also did that in 2017. And by that time, there were like 40,000 people in all the studies that he reviewed, and it was still zero effect for the interaction term. There is no, the gene does not matter. The version of the serotonin transporter gene has nothing to do with whether you'll be depressed or not. Okay? It's unfortunate. Your book does talk about the CASPI study, and they say, you know, like, oh, there's some controversy there. Like maybe, you know, it didn't replicate once or something, but like they don't tell you that the overwhelming thrust of the data from science is that it's just false. Everybody knows that. So why is it false? I mean, maybe it's because CASPI fudged the numbers, but I don't think so. I think it's probably, what probably happened is that CASPI looked at the effect of stress. He was looking for that bucket. And do you know how many genes are in your genome? It's like 30,000 or whatever, right? So he probably looked at the relationship between stress and like hundreds or thousands of genes. And this was the one that looked, you know, like it was an interesting effect in his data set. So he published just that one. And that's what happens when you do that type of thing. You can find something, but it's an artifact. It was just random chance. And that's why it didn't replicate in other studies. All right, I think I got a little summary slide here. So it looks like CASPI's sensational result was a type 1 error. In statistics, that's when you think you found something real, but it was really just noise or randomness in your data.
And what's type 1 again?
A type 1 data is when you think you found something real, but it's really just noise or randomness. So it'd be like, you know, getting a bag of M&Ms and like they're mostly brown ones or whatever, and you're like, I wonder if there's always more brown. But like, actually, no, it was just that one bag. Capiche?
So they just found it by chance?
Yes. So in reality, the 5-HTP genotype is unrelated to depression. And that's all I have to say about the CASPI study. How are we doing? How are your brains? Are you okay? Ready for some more nuance?
I think I'm ready for a sad song at this point.
Okay. Maybe I should have saved it for now, yeah.
Did Caspi like remain groundbreaking and relevant until like that meta-analysis came out?
Caspi still claims that he's right. He's like, everyone else's study is crappy. That's why they didn't find the same thing as me.
Okay.
Yeah. And it's interesting. We're actually going to learn about Caspi later on in the semester. And he found another result, which is actually very similar for a different disorder, a gene-environment interaction, which did replicate. So he still has some cred.
Okay.
His first name is Abshalom. Isn't that like David's son or something? Or Solomon's son? I don't know. All right. So, is there any evidence that we can trust for this monoamine theory, other than the aspirin argument, which is that SSRIs work? Well, okay, there actually is. It's not completely lacking in evidence. So there are some animal studies we can look to for this. And a man whose name is Marty Seligman, the father actually of positive psychology, and he was the advisor of one of my colleagues I used to work with when she went to grad school at Penn. A long time ago, he shocked some dogs a lot. He put them in a cage, and he would shock them continuously. There was no way the dogs could get out of the cage. And so he created an environment called learned helplessness, where the dog would just realize there's nothing they can do to prevent these shocks. And so eventually, of course, you shock a dog in a cage, he tries to get out or whatever, he yells. But eventually, if you keep doing it long enough, he will just lie there and take it because he realizes there's nothing he can do. He gives up. So that's called learned helplessness. Now, that was a nice thing, right? Well, let's shock some dogs and, okay, they lie down. So they felt like, okay, this is sort of an animal model of depression. That's what people do. Life shocks the crap out of them, and they have a lot of stress in their life, and they can't get out of it, and they just lie down and take it. Analogously, they're saying this is not unlike human depression. So, okay, whatever, maybe you can criticize that, or you think it's partially true. They at least, have a potential point. So what Seligman did is they killed those dogs, and then they ground up their brains, put the brains in a centrifuge, and measured how much serotonin was in the brain. Okay. Remember I told you you can't measure serotonin in a living brain. That is true. You can measure it in a dead brain, though, because you can put it in a centrifuge. Yeah.
Is it possible to have a ballpark estimate as how much serotonin in the brain if you take a blood sample?
No.
Blood-brain barrier, if it gets dissolved through the blood.
Yeah, I mean, I'm saying no, mostly by assumption, but I'm pretty sure no. Yeah. Yeah, because serotonin doesn't live in your hand. It's primarily in your brain.
I remember hearing that that's possible for a brain that's smaller than normal to be just like normal because of activity. So wouldn't it be a problem if they're not able to measure the activity of the serotonin?
No, because the whole theory here with the chemical imbalance is that you don't have enough serotonin in your brain. It's not about the activity of it, it's about an actual lack of the chemical. That's the theory. And the theory is that's why SSRIs help, is because we give you more of it. Okay? So in this study, this is what they did. It's kind of mean to the dogs. But they found that indeed serotonin pathways in the dogs' brains were changed. And I believe there was less serotonin overall, at least in some parts of the brain of the dogs that they ground up their brains. Yes?
How did they, it says change serotonin pathways?
Yeah.
How did they,
I know. I don't remember the details on that. But there were some changes that were more or less consistent with the chemical imbalance theory.
it sounds like ground up brain, obviously, the pathways.
Yeah. Maybe some of them they didn't grind up. Maybe some of them they sliced up and put in a microscope or whatever. Yeah. Tommy, you had a point a minute ago.
So you said that serotonin can't survive out of the brain?
What did I say?
You said that serotonin can't survive outside of the brain?
I don't think I said that.
Oh,
Serotonin is a molecule. It's not alive. It doesn't survive.
I mean, survive, never mind.
Well, it's not in your hand, is what I said. Yeah.
So they keep it in the brain and then they look at it?
Yeah, if you kill a dog, chop off its head, the serotonin's still in there. and then you carefully, quickly take the brain out, put it in a centrifuge, you can measure a bunch of different chemicals in the brain that way. Yeah.
How did they know the serotonin amounts before they chopped up the brains if they weren't able to do that?
Terrific question. How would you do it if it was your study?
They can't chop up the brain and then put it back together and then
No. So you want to know, you're Marty Seligman, the year is 1968, and you want to know what is the deal here when I do my learned helplessness thing and make a dog depressed. What happens to serotonin in his brain? How could you answer that? Because you're right, you don't know what the serotonin was before you put it in the centrifuge. All you have is that one data point for that dog. What could you do? Are you at a loss?
well, you could probably try to measure something else, but you can't measure exactly what you're measuring.
No, there's a way to do it if you only measure serotonin.
There's a way to do it. Then why didn't they do that afterwards instead of talking to them?
Good?
They have to do a control group.
Control group! Control group! Yes! Let's take some other dogs that are just like the lab dogs. They hang out with us, during the day. We don't shock the crap out of them. And look at their serotonin levels, assuming they're normal.
What aren't, couldn't it be different per dog?
Yeah, let's get like 20 of them and assume it averages up. All right? Would you be convinced?
When was this study done again?
Like the 60s or 70s or something. Yeah. Through, randomization. Let's say we take 40 dogs, okay? 40 dogs. And we say, I don't know, this one's a Saint Bernard, that one's a poodle. Like, what am I going to do here? Who's going to be the ones that are shocked? We could totally have a bias problem where, if we only use the poodles to be shocked and the Saint Bernards to not be shocked, then we have a problem there because the serotonin levels could be different based on breed. But instead, what you do is you use a random method to assign. Like, you take every dog and you flip a coin. You say, okay, you're going to be shocked, I guess. You're going to be not shocked, okay? And if you really do it randomly, and you do it with enough dogs, like 20 in each group or 40 in each group, you can trust the results compared to the control. Okay? Phenomenal. You guys are understanding. So that's a pretty good piece of evidence. And the other evidence is the antidepressants work. It's the aspirin argument. Now, there's one more piece of evidence I'm going to tell you about, which is even more powerful. Postmortem studies of human suicides. Here we have some mixed results, but there have been some studies, I think the majority, showed lower serotonin levels in completed suicides as compared with brains that died of like a heart attack or whatever. Now, there are some problems with those studies. Most of the suicides in those studies were violent deaths. And we don't know if that could affect the serotonin measurements when you put that brain in a centrifuge later. If someone shoots themselves in the head or whatever, that could affect things. So that could affect the overall group by if you had a few people that, did that. Yeah.
What do you mean by violent suicides?
Guns or crashing your car over a bridge or jumping off a high building, as opposed to poisoning. Poisoning is the main alternative to a violent death. So in both of these, the dog one and the suicide ones, it's correlational evidence that is consistent with the monoamine theory. But it's not really causal evidence. All right, but this is the evidence for the monoamine theory. It's not nothing. We basically have antidepressants work, the dog thing, and the suicide thing. And the suicide thing isn't like a slam dunk, but it's a decent evidence that there's something going on with serotonin there. So this is the real evidence for the chemical imbalance theory. Now, I'm going to tell you some more things though, more nuance, which is now I'm going to tell you some evidence that is against the theory. So that was the evidence for the theory. Now this is the evidence against the theory. Okay, so remember with schizophrenia, we had this joyous occurrence where that surgical anesthetic blocked dopamine and cured psychosis, right? Do you remember that? That was basically the aspirin argument. Aspirin, cures headaches, so maybe a lack of aspirin causes them. But that was what the deal was with schizophrenia. But we didn't just have that. We also had the fact that if you give L-Dopa to people with Parkinson's, you give them too much, they become psychotic. So we had, going both ways. Dopamine giveth and dopamine taketh away, psychosis. So guess what? People who are trying to support the chemical imbalance theory of depression a long time ago thought of that, and they were like, serotonin taketh away. Serotonin can heal depression. Can a lack of serotonin cause depression? Can I cause depression in a human being by taking away their serotonin? They were like, let's try it, baby. So they did this thing called a tryptophan depletion study, where they depleted the tryptophan in your diet. Now, tryptophan is the chemical precursor of serotonin. It is also the thing that allegedly you eat, turkey and on Thanksgiving and it makes you tired.
So what was it again?
Tryptophan.
What you described it doing?
It is the chemical precursor of serotonin. So just like L-Dopa, it is actually the chemical precursor of dopamine. It's what your brain uses. It's the raw material your brain uses to generate dopamine in the form that it actually uses. Serotonin is the same deal. It uses tryptophan to build serotonin molecules. So some researchers said, hey, if we can deplete tryptophan in someone's diet, make it so they don't have any tryptophan, their brain won't be able to produce much serotonin at all, that's going to make them depressed, right? This will be the L-Dopa equivalent for depression. The problem was those studies did not pan out that way. Depleting tryptophan does not cause depression. I apologize, the thing isn't that good. So it was potential causal evidence of the monoamine theory, but it goes against it because the results did not pan out that way. Depleting tryptophan. Cool idea, great idea. Sucks for the people in the study because potentially you're making them depressed, but it turned out you actually didn't make them depressed, so it was okay. Yeah.
You kind of just mentioned it, but I was wondering if that did, like, it might not have shown causal, but like what results would happen? Like, was there any,
There's no difference between people who have tryptophan depletion and people who don't.
but they were able to, like, onset depression do this?
No, that's what they were trying to do. They said, all right, you want to be in a study? You're either going to get a placebo or actually, it was a diet thing. It wasn't a placebo. They said, we're either going to alter your diet so you have zero tryptophan in it. You don't eat anything that has tryptophan like turkey. Or you're going to eat a normal diet. You want to be in the study? And you're like, okay, sure. So some of the people did this thing where they didn't eat any tryptophan for like 2 months or whatever. And then they were just like tracking people to see if they got depressed. And the people who didn't eat any tryptophan didn't get depressed any more frequently than the other group.
Or was there any changes in anything? Like, I understand they were trying to see if it would cause depression, but like, was there any other?
Like it made them sleep more or something like that? Yeah. Not to my knowledge. I don't know. The one thing we care about for the present moment is it didn't cause depression. All right. Now, here's another interesting thing. This goes back to Kasaya's question with the assumption that we can measure serotonin levels in the living brain, which we cannot do. However, recently we have developed the technology to measure the concentration of serotonin receptors in the brain. So it's literally these guys. These little receptors, we can measure how many of those you have. It's not the same as measuring your serotonin concentration overall of the actual molecules, but it's something related to serotonin, so we can measure how much of those you have using what's called PET imaging. PET imaging is hot as heck in research right now. It's a technology that's being refined a lot and getting better every day. And what it is they inject in your body, in your arm, they inject a glob of radioactive goo. It's literally like radioactive. And what's the deal with radioactive stuff? Well, it spews out It's like constantly beaming out like a neutron or something like that. So basically, they can use the radioactive goo. It goes throughout your body. It goes into your blood and goes all over. But they can manipulate the goo molecularly so that it likes to congregate in certain areas. So they can make some of it congregate on these guys. They put a little thing in the goo so that it hangs out in serotonin receptors. So this is how we've been able to measure serotonin receptors in the brain, is through this radioactive goo called PET, positron emission tomography. But this is the result we found. It's just like tryptophan. Look at these two groups. This is the midbrain concentration of serotonin receptors. In controls who are not depressed, the average is about 255 or 260, I would say. People who are depressed, it is 245, I don't know. And you can see there's massive overlap between those groups. Here, this person is here, this person's here, they're a control. This person's there, they're depressed, this person's also depressed. There's no difference between these two groups, statistically, or there's no meaningful difference between those two groups. So, guess what? This is evidence against the monoamine theory, because the theory is lack of serotonin causes depression, and we can't measure serotonin in a living brain, but the thing we can measure that's related to it, serotonin transporter density, is identical in people who are depressed and people who are not. Okay? So this is, to me, pretty strong evidence against the theory. Does that make sense to you guys?
So with this study, I mean, it makes sense that they're measuring serotonin receptors, but how would it be evidence against it if you're still not measuring the serotonin? Because like the whole issue is like there aren't enough serotonin to bind to the receptors, so like is the assumption that like the receptors just aren't there?
Yeah. So you're saying it's not actually measuring the serotonin molecules itself. So just because we call a null result here, doesn't mean there's not a difference in the actual molecules. You're correct. But if there were a big difference in the actual molecules, often your brain's able to adapt to that. So if you didn't have enough, you'd make more receptors to make up for it or something like that. So yeah, you'd expect maybe there would be some sort of difference that we'd see here. But you're right, it doesn't totally prove that there's not a difference in the concentration of the actual chemical. Absolutely. Note, though, that there was one group that was different, and that's the people who had attempted suicide. Like they're down around 200, so I'd say this is a meaningful difference between the other two groups. So it's not depression per se, but maybe it's something about suicide that is related to low serotonin receptor density, or alterations in the serotonin system, if you want to say it generally. So serotonin transporter density is normal in depressed people, although it is lower in folks who had attempted suicide. I would not bet my house on this because it is a small sample size, but it is all the data that we have so far. So also the CASP study is false, so 5-HTP gene, whatever one you have, is unrelated to depression risk. So that's the evidence against the monoamine theory. All right. So bottom line, there's some evidence that low serotonin levels happen in depression, e.g. the dog thing, e.g. suicide brains that we grind up and put in a centrifuge, and even suicide brains in that PET study I just told you about. And boosting serotonin makes depression go away. But this is done with dirty drugs that do other things as well. It doesn't mean that a lack of serotonin was the cause of depression to begin with. Just like the fact that aspirin cures headaches does not mean that a lack of aspirin caused the headaches. There is no evidence that I'm aware of that low serotonin levels cause depression. They could just as easily be analogous to a fever, right? Think about it. There's this biological thing. Everybody who has the flu has a fever. Maybe the fever causes the flu. I'm just enjoying the whole fever thing. So maybe serotonin levels being low is like a fever. It's the way your brain responds when it's depressed. It doesn't mean that it caused your depression, nor does the fact that you have a fever mean that that's why you have the flu. Obviously, you have the flu because you have this virus living in you. Why do we have depression? Who knows? So why is there a widespread belief that the chemical imbalance theory causes depression? Well, because drug companies lie. These are a bunch of quotes from drug companies which don't say that there's proof that the chemical imbalance theory is true, but they heavily imply it, and most people aren't careful enough when they would read an advertisement like this to like wonder what the actual data are, which the data are what I just told you they are in this little review lecture here. So when you're clinically depressed, one thing that can happen is the level of serotonin may drop. They don't say, we know this causes you to be depressed, because we don't know that. But they say, so you may have trouble sleeping or feel unusually sad. Serotonin helps, Prozac helps bring serotonin closer to normal. And the medicine doctors now prescribe most is Prozac. So like, it's heavily implying that the cause of your depression was this low serotonin levels, but we don't know that. It could just be that they're like a fever. And there's other ones too. So maybe the monoamine hypothesis. Oh, do we have a presentation today? Please tell me we don't. Oh, we do? Who? It's you and who else? Just 3? 4? Okay. What are you presenting on? Bipolar depression. Yeah. Are you going to be around next class? Would you mind doing it next class? No, I mean like on Tuesday.
Oh, sorry.
Yeah, yeah.
I'll be around on Tuesday.
Would you guys mind flexing to Tuesday? Thank you. I appreciate your flexibility. I want to get to one more thing. That's why. So maybe the monoamine hypothesis relies heavily on the aspirin argument to support it. But at least SSRIs work. And that is good evidence, right? But here's the thing. Do they? Do antidepressants work? Sorry, I try to be dramatic every now and then, and it's, I don't know what's wrong with me, but the answer is complicated, but it is not yes. The answer is not yes. Antidepressants do not work. Okay? I mean, they do work, but it's complicated. So let's talk about it real quick. In fact, I don't know. Maybe I can save time. Oh, and it says my video is unavailable anyway. Okay, I'm definitely going to save time. I'm not showing the video. All right, so here's another meta-analysis. Don't look at it. Don't look at that meta-analysis. Let me explain something first. Remember we were talking about dogs a few minutes ago? I'm sorry, A can't see. I can only see your silhouette. Like it's really hard for me to see you. What's your name?
Oh, sorry. Wait.
No, Molly.
Oh, yes, Mom.
No, not you.
Not me.
Sorry, the one behind you. See, no. Yes. Naomi. Yes. What's your last name? Tripp. Right. Got it. So Naomi was like really this like hardcore skeptic, and she didn't believe like the dog result or whatever, which I love. In studies, you've got to have a good control group, and you've got to really randomize, like I started to say, flipping coins or whatever, choosing which dog is going to be shocked and which dog isn't going to be shocked. And if you really find that all the ones that I randomly assigned to be shocked have less serotonin in their head when I grind it up than the ones who I didn't shock when I grind up their brains, then you can believe it. It's true. So this is called randomization. It's like the heart of a lot of science. So whether antidepressants work or not, like Freud used to have people in his office all the time, like the Rat Man. Remember you read the Rat Man? I haven't really talked about that reading, but I hope you were able to at least like skim it. There's a lot in there that I don't understand, so don't worry if like you didn't get every word. But Freud felt like this guy's like 20 years old or whatever, and like he healed the Rat Man. But Freud doesn't really know if he healed the Rat Man or if the Rat Man just happened to get better anyway, or if it was some kind of placebo effect, like going to a famous therapist. He's like, wow, I feel better already. I'm going to this famous therapist, like maybe it was just like something like that. To really know if something is an effective treatment, you have to have carefully controlled randomized trials. So that's what this is a graph of. This is a graph of many, many studies that are all carefully controlled randomized trials. And these are studies of antidepressant medications, such as SSRIs or SNRIs or whatever. And for each study, this is showing the results for an antidepressant and also the results for a placebo, the control group, okay? Where you take a sugar pill, a pill that is just literally just has sugar in it. And here's what we see. So first of all, you got to understand the X and the Y axis, right? So let's start by doing that. And let's start by doing that. So HDRS scores at intake. This means Hamilton Depression Rating Scores at intake. This is a famous interview for depression. Everybody uses, and it's like, how much has your sleep been affected? How sad are you? Have you had feelings of guilt or worthlessness? It's just going through the DSM symptoms and assigning like a number of severity to each symptom, okay? It's a very good interview. So this is showing how severe your depression was, basically, at intake when you began treatment. And this is how much your depression changed during treatment, okay? So what do we see overall? Never mind the gray versus the white bubbles. We see overall that points tend to be low over here and higher over here. Save these little guys. But in general, mostly, things are going up as you move to the right. What does that mean? It means if you were not severe at the beginning of treatment, you're not going to change very much. There's not going to be very much change in your depression scores if you weren't depressed to begin with. So, okay, fine. But the more we see here, the more change we see, the more healing that drug did for you, the more it changed your depression scores. Okay, fine. So now let's look at this graph and try to ascertain whether the placebos are different than the antidepressant medications. And I will posit to you that it's not a simple answer. It's sort of like two answers. If you look at this graph, I drew this blue line right here. To the left of the blue line, there is no difference between placebos and antidepressants. To the right of the blue line, there is a difference where you see these grays tend to be higher than the whites. So, and the grays are the antidepressant medications. So for severe depression, it looks like the antidepressant medications do beat placebos. But for mild to moderate depression, like if you had a Hamilton depression score of less than 25, there's no difference between placebo and antidepressant medication. Okay? Yes?
I've noticed that in a lot of like pharmaceutical commercials, say like, if you have moderate severe ulcerative colitis,
Yeah.
severe pain. Is this the case with like most medications where if you're like if you're below moderate, it's really not going to do anything for you?
I don't know. I know what you're talking about with those commercials, but yeah, I only know for this. So, yeah, so in the United Kingdom, they have a more advanced healthcare system than us. They do not prescribe antidepressants for mild to moderate depression. In the United States, where we're basically owned by drug companies, doctors prescribe them all the time, like Skittles. They're the most prescribed medicines in the country, more than aspirin. Antidepressants are the most prescribed. And it makes drug companies a ton of money. And it helps people. Okay, so this is another nuance of this lecture. I'm not saying antidepressants don't work for mild to moderate depression. They do work. They change your Hamilton Depression Rating scores. They just don't work better than placebos. Placebos also work. Capiche? If you miss that, you miss a big one. Placebos are effective treatments for depression. Sugar pill, it helps. It just, maybe it's having hope that, maybe this thing will help me. That makes people better. Antidepressants also work, they just don't work better than a sugar pill for mild to moderate depression. Now, if we look at severe depression, there is a difference. SSRIs work better, even better than placebos for severe depression. And you'll also notice the size of the bubbles. I haven't talked about that yet. The size of the bubble is proportional to the sample size of the study. So the bigger the bubble, the more you should believe it. So most of the weight of the studies is in this range, in the moderate range. When we get to the severe range, we don't have too many people. So it looks like the antidepressants are beating the placebos out here, but we need more data out here to be confident in that. But I would say that if I had to take a guess today, I would say that antidepressants do beat placebos for severe depression. But I would say, let's get some more data on that, please. All right, yes?
Was the study that just with antidepressants not recommended causing?
That's right. That's right. So, I don't know, this could be on the exam too. It's not on the exam yet, but I might put it there. So what questions do you have about this? There, you got it. I am concerned about what you're going to go tell your roommate, and like, antidepressants don't work, or something like that. That's not what I said. I said they do work, they just don't work better than placebos. Placebos also work. Somebody challenge me on that, or like, tell me why that bothers you or something.
Just a question. Are the placebos usually a placebo-like pill?
Yes?
Okay. I wasn't sure if there were like any methods that were.
Oh, yeah. No, it tries to be a good control for the antidepressant medication, which is a pill. So we give a pill as a control. It's good science, yeah.
Can you get prescribed a placebo?
Oh, right. Good question. No, you can't, because then you would know that it's a placebo. Like, well, what are you going to do? Be like, here's some Prozac, and it's really a sugar pill? That wouldn't be ethical. So yeah, the problem is these placebos only work in studies. You can't actually use them to fix people. It's a bummer. Yep. Good question. Yeah. One other thing I'll say, and then I'll take your question, Dan, right? Yeah. Is you may look at yourself or your roommate who's like believes that they took an antidepressant and it was effective, and maybe you had moderate depression. Well, these are averages across many people. So this doesn't say anything about individuals. There could be some people that they are effective for, that antidepressants are effective for. This is also averaging across many different types of antidepressants. So, and maybe, as we were talking about earlier, maybe sometimes one antidepressant works for you, another doesn't. So maybe there are particular combinations of people and their brains and biological stuff and particular versions of antidepressants that do beat placebos. We just haven't got there yet scientifically. So this is all we have, is kind of averaging across all of them. But what I'm trying to say is, like, you don't have to believe that, like, I don't want you to feel like a sucker or something like that. If you've taken an antidepressant and it's helped you, it doesn't mean you're dumb or that you're a sucker and that it really was just a sugar pill. We don't know that for you. We know that on average, it looks like there's no difference between the sugar pill and these for mild to moderate depression, but that doesn't say anything about your experience. Yeah, Dan.
But, so why does it even matter that it's equal to a sugar pill? Because we can't give placebos to people ethically. And it does still get better. Does it even matter that it isn't? Because it's still helping.
Right. Yeah, you're right. It doesn't really, it depends on what you think matters. So in England, I told you, they don't do it for mild to moderate depression because it doesn't beat a sugar pill. But here, the thinking is like, Well, the sugar pill works and we can't really prescribe a sugar pill, so we might as well give this to people. Yeah. And the difference, even the difference up here, or if there's a very, very slight difference down here between the two meds, that could partially be due to the fact that antidepressants are just better sugar pills. They're better placebos. The sugar pills in these studies suck. They are literally just sugar. So there's no side effects to those drugs. So if you're in one of these studies, think about it. You're like, oh, I'm depressed. I'm hoping this pill works. You know, my life is tough. And by the way, I also have like dry mouth from the stupid pill that I'm taking. Wait a minute. I have dry mouth. I must have the real pill. I have hope, right? As opposed to the person in the placebo group, doesn't get the dry mouth, doesn't get the sexual side effects, doesn't get the weight gain, whatever. They don't have the hope. The physical changes in your body make you feel like something really is happening here. So I think if the placebos were better chosen to actually have side effects, then it would be even more of a level playing field, possibly even for severe depression, but that's totally unaddressed. And it probably won't be addressed because there's no drug company that's going to want to do that study, because all it could do is prove that their drug doesn't work. So it's never going to be funded. So there you go. I think this is probably a pretty good place to stop. Yeah? All right, thank you, group, for going. Next time, please remind me. And I'll see you guys on Tuesday.